Hey everybody, this is Alex Merced. Welcome to another video talking about different data concepts. Today I want to talk more about data storage and just going to the actual storage system and understanding sort of like how that works, and going all the way to distributed storage systems like HDFS and object storage and just kind of like their architectural differences. That's sort of the scope of this video. Again, if you like these videos, make sure to like and subscribe, leave a comment, follow me on Twitter and LinkedIn, and let's go. Okay, so your traditional file systems like you might be using on your laptop or your computer, these file systems are designed really for like one storage media, okay? I might have different hard drives, but let's just pretend right now I have one hard drive, okay? So here is my hard drive. Okay, it doesn't matter what kind of hard drive it is, but the idea is that what the storage system on my laptop is doing is tracking sort of logically where is sort of a logical abstraction to data that's physically stored in my hard drive. So it means the actual data that's written to the hard drive. Okay, so what I experience is I might experience like a folder. So to me, I see a folder, /home. Okay, under /home, I see like my username folder. Okay, so let's say /AlexMerced. And then under that file, I might actually have like a file. Okay. And we'll say like this is my .bashrc file, some random file. Okay. So this is sort of what to me, logically, this is what I experience. Okay. But essentially, under the hood, what's happening is that the computer is tracking sort of, hey, there's this file called /home /AlexMerced /.bashrc. And it's going to track like where on the hard drive this is stored. Like where is it, like the actual physical blocks of memory that this is stored in, and some other metadata like when it was created, whatnot. And using that metadata, it's able to then go locate that file on the hard drive. And then basically this whole structure of directories is more of a logical abstraction for me to interact with all the files stored in the hard drive in a much more intuitive way. Okay, again, so there's always logical, which means not actually so like the data physically in the hard drive, there's no folders in the hard drive. There's just blocks of memory, and files are stored in different blocks of memory. Okay, but to me, I logically experience files and folders. Okay, and then that creates a path, and that becomes the name by which we attach a file on the hard drive. But the problem is it's only dealing with one device. So basically this is pointing to a specific storage on a specific location and only one specific location, which is great for my laptop, not great for really, really large distributed systems. In large distributed systems, one, you don't want to have just one copy of the data. And oftentimes your data is not just in one hard drive. Okay, you might have stretched across many, many computers. Okay, so you might have several computers, which we'll refer to as nodes. Okay. Okay, and in that case, you might have a file called, /this/that/file.extension. Okay, whatever the name of the file is, and you don't want that file just on one node, because what happens if if the file is only stored here, okay, then if that computer falls apart, that file is no longer available. Okay, so when you have these large distributed computing systems where you're using multiple computers to provide data to lots of people, okay, think about just how all your favorite cloud vendors work. What you're going to want is you maybe want this particular data to be on maybe 3 nodes. Okay, so that way if this one shuts down, it can still go get that same file from here and here. Okay, so in this case, this has metadata on the multiple locations of that data. Okay, so it's no longer a name that's attached to a single physical location, but it's attached to a series of physical locations, also referred to as replication. We're replicating the data across multiple nodes. Okay, sort of the most well-known and sort of original system to do this was a system called Hadoop. Okay, so in Hadoop, you would have your master node. Okay, that would sort of basically when you interact with the file system, which is referred to as HDFS, the Hadoop file system, okay, you'd be interacting with this, and you would have a bunch of worker nodes. So all these would be worker nodes. Okay, and essentially when you ask for a file, get rid of that one. Okay, basically I would ask for a file from the master node, so I'd say, hey, I want this/this/file.ext. I would ask, hey, I want this file from the master node. That's who I'm sending the directions to, and the master node would know exactly, hey, which worker nodes have copies of that file to go get me that file. Okay, and then deliver me that file. Okay, and the beauty of this is, as long as I had that same data set replicated across multiple nodes, I could have constant uptime, because basically one node gets shut down and needs to go for maintenance. Well, that file is available in like 2 or 3 other places. Okay, and also the idea is that when you interact with, even though there's like 6 computers here, from the point of view of the user, they're still only dealing with one big file system. Okay, so they just know that, hey, there's a files and folders in this big giant hard drive. Okay, so to them, this all operates like this one big hard drive, this one big system of files and folders. Okay, so it creates a nice logical abstraction for the end user. Okay, but provides that robust scalability on the back end. Okay, so this is, and so when you're dealing with huge amounts of data, so imagine you're like a company like a Netflix or an Uber or whatnot that has so much data coming in on a daily basis because so many people are getting rides, so many people are watching streaming movies, that there's no one computer that's just going to be able to store a full data set. Okay, chunks of that data set is going to be stretched across multiple Parquet files probably. Okay, and those Parquet files, some of them will be here, some of them will be there, some of them will be here, and I'll need to pull them when I need them. Okay, so this offered a really nice way to kind of be able to have a scalable sort of storage system. And this became the impetus of sort of a dumping ground for data, an architecture called the Data.Lake. So the idea, you would set up something like a Hadoop file system, and then basically all your data, not just your structured data, the data that's inside like Parquet files, that's in tables and that you got from databases, but all your audio files, log files, sensor data, all this other stuff would also just get dumped in here. Okay, so that's the idea of Hadoop, but in more modern times, people have moved away from Hadoop, just because, one, it's really hard to manage. Okay, there's a lot of work in managing these, adding nodes, subtracting nodes, trying to determine, hey, what happened with the node. Also, just like the way Hadoop replicates, it doesn't replicate a single file. What it does, it replicates a block. So you might have a block, block 12. Okay, that'll be the name of the block. We'll give it a little color here, make it real small. Okay, and block 12, which might be like 128 megs worth of files, is located on 3 here. So you're not saying, hey, this file is on 3 different computers. You're saying, hey, this file is part of this block, and then this block is like replicated between these machines. Okay, that's essentially how that would work. Okay, nowadays what you're starting to see more and more of is what's called object storage. Okay, and object storage ditches the files and folders. Instead, what happens is you would have buckets. Okay, okay, cool. We'll say, yeah. And then what would happen is that any file, basically, generally each bucket is attached to a region, because you're using with this, you're using one of the cloud providers like AWS, Azure, Google Cloud. You could also create your own on-prem object storage with tools like Minio and Pure Storage and others. So there are alternatives, ways you can do this, but generally the idea would be like, I would create like a bucket, and AWS has different regions, right? So like basically I would have like maybe like US East 1, Okay, US East 2. Okay, and we'll say US West 1. Okay, so there'll be all these different regions that represent data centers that AWS has all over the world. Okay, and then each of those data centers would have, again, a big distributed file system. So again, it would have like nodes to however their file system is under the hood. Okay, so let me just do this and make that like that. Actually, let's do it like this. Okay. Oh. Make sure I get all the buckets, all the nodes. Control C. So there's all the nodes for located in US East 2 and US East 1. Okay. So the idea is that you could choose like which region you'd create your bucket in. So I'd say, okay, hey, I'm going to create a bucket in US East 1. You give it a name. Okay, so then the name of my bucket, let's say, is, slash Alex1. Okay, so now if I were to save a file in this bucket, the Alex1 bucket, just like you saw with like Hadoop, it would get replicated off different nodes in that data system and that at that data center, replicated by whatever factor they decide to replicate it on. Okay, but the thing is that basically it gets, instead of it being sort of just a file, it is treated as what's called an object. Okay, so essentially I would create like an object. So let's do that. Let's make it like, let's use a different color. Okay, so this would be an object. And we'll say, hey, this is Alex1. So the first part is always the bucket. And then anything, you can have literally anything afterwards, so, which would look like a folder. It would feel like a folder, but there really is no, it has no meaning. Only the bucket really has a meaning because the bucket can be located in different regions. The rest is just part of the name. Okay, so I could just say, hey, folder slash file dot ext. Okay, let me just stretch that out so we can get that all in one line. Okay. So that file will get, so this would maybe point, so this would point to a file that I had stored in this bucket, which may be replicated across these different nodes. And this object would generally have metadata regarding what it's located and any other rules, because also oftentimes these object storage providers, not only do they have the ability for you to store data and replicate it, and then again, they replicate it at the object level. So the object is replicated between multiple nodes. So this particular object is replicated across like these 3 nodes or whatever. But oftentimes they might even have tiered storage. So in that case, in the metadata may say, hey, what type of storage it is, which will determine sort of like how it prioritizes the fetching of the data, with particular nodes it might store it on. So there might be some high performance nodes and low performance nodes. And this is usually done sort of in the name of sort of like cost savings. So data that you don't plan on accessing much, you can store in a lower data tier, while data that you plan on accessing very quickly, you can store in a much higher tier that uses much quicker storage nodes and is higher priority when it's being fetched. Okay, and then you can pay sort of for the type of access you need. And from the point of view of the user, you're just dealing with files in a bucket. Okay, so to you, you'll still experience it like you experience a traditional file system. But again, really, the bucket is the thing that actually kind of determines a lot of the characteristics, because again, you might have a bucket that stores data in a particular tier that is part of a particular region, and then the prefix, so any kind of pseudo files and folders in between, are just a name. They're just a name. There's no actual like folder or file. They're just a way of naming the objects in the bucket. Okay, but same concept. You're replicating the data across multiple nodes. And the idea, again, the benefit of all this over the original sort of file system, so basically above this, is that we're not mapping these names to a single physical location. We're mapping names to where we can find it across a distributed system, a distributed storage system. So that way we can have redundancy so we can have maximum uptime. So the idea is to make sure that I can always access that file, and also I can access it performantly. So that way, if like a lot of people are accessing that file, we can share that work across multiple nodes and getting that data. So there's performance benefits, um, access benefits, as far as like, again, having constant ability to access the file and minimal downtime. And again, oftentimes with object storage, you're using oftentimes using a cloud provider. So oftentimes it's a lot easier to maintain because you're not the one maintaining the infrastructure. Although even on-prem object storage providers that generally follow the same rules as the cloud, like the same sort of structure, oftentimes are still much easier to maintain than the more older school Hadoop file system, which is why a lot of companies, even if they're looking to stay on-prem, and when I say on-prem, what I mean is on-premises, like meaning they manage their physical computers instead of letting a cloud provider manage the physical infrastructure, are still making migrations over to object storage providers, like again like Minio, like Pure Storage, on the local systems. And this is like a place where a platform like Dremio is really useful because Dremio, which is, again, if you watch the intro, the SQL videos, and the SQL with Dremio videos, we've talked about this. But Dremio can connect to many sources, so it can connect. So if you're working with Hadoop, you can connect Dremio to your Hadoop cluster, and then connect Dremio to your object storage, and allow everyone to work from one place while you move data from point A to point B without them having to think about really worrying about where the data is, because the data that they have access to is always in one place. Like they just access it through Dremio. So that's become a popular method to migrate from one platform to another. But again, this is Hadoop, sort of like the OG distributed file system. And then nowadays you're starting to see more and more paths to sort of like this type of structure. But hopefully you guys enjoy that, and hopefully that gives you some more understanding of the space. But my name is Alex Merced. Again, if you like, subscribe, leave a comment. I'll see y'all later.